All right, what we have here is we're going to be talking about how to find the least squares regression line, and how to find residual, how to create a residual plot, and how to use a residual plot to figure out if we got a line, if it's a linear model. And we're going to use a TI-84 plus right here to help us figure this out. So right here, you have some data of ninth graders who have different backpacks. And we're going to say this right here, this person is going to be, our body weight is going to be explanatory variable x. And then we have backpack weight, which is going to be our y value. We're going to calculate our equation of a least squares regression line, also known as an LSRL, okay, by going to our stat and going to edit. In list 1, I inputted all of the body weight for x. So if you want to do that, you can do that. List 2, we're going to put all the backpack weight, all right, into list 2. From here, we're going to go to stat again. We're going to calculate. We are not going to take number 4. This is when we talk about algebra, but we're going to calculate 8, a linear regression line where we have a plus b x. A is the y-intercept, b is our slope. So we're going to take 8 right here. If you have this, you're going to have different lists of frequency. We're just going to calculate this out, and we're going to calculate this, and bada bing, bada boom, this is what we have for our answer. So what we have right there is that y hat, all right, y hat, which is the predicted values of the backpack, is going to equal 16.264. All right. Or if we want to round that, I probably should put 5. Okay, round 3 decimal places. 5. And it's going to be plus our slope 0.091. I'll go like that, x. And that's what we have there. Now, from here, what we can do is we can create a residual plot. Now, in order to find the residuals using our TI, what we can do is we can go back to second stat. And what you see down here is resid 8. If you press 8 and press enter, this will give you the residuals from this equation. All right, if you recall, residuals are the actual minus the predicted. And so what the calculator does for you, it uses this linear regression line that we found and calculates all the residuals for each one of these backpack weights at 120 pounds, 187 pounds, and so on and so forth. So from here, we want to create a residual plot. So if you go to second stat plot right there, and you can go into here, and what we can do is turn it on, and you go down to here, we want to do a scatter plot. List 1 is going to be explanatory, but now our outputs are going to be residuals. So if you don't remember how to do this, go to second stat, press 8, and that's going to push that there. You can put pluses if you want to. Now, we want to change our window because in here, we want to make sure that we have the correct values that we want to use. So we want to see this. So we're going to start, maybe I'll start at 90. Okay. We know that the lowest value is 103. But I'm going to start at 90, and we see the largest value is 187, so I'm going to go to 200. I'm going to take my scale at tens. Now, our y values are residuals. So I'm going to just say 10 to negative 10. And so once we have that, we are going to graph this, just going to y equals, make sure our plot 1 is on, and we can graph this. And what you can see are all of these different residuals, and I'm going to just put that right there. Okay, so you can see at 103, we have a residual that's just below the x-axis, and you can see all these different values there. Okay, a little bit of a little bit of a change in the y, you'll be able to see those different values. Well, now the question is to answer this third one, what does the residual plot indicate about the appropriateness of the linear model? Explain your answer. Well, do we see a pattern here? Do we see a pattern? Well, definitely appears to be a pattern because it appears that we have, this is going to be kind of all here, then we go over there, okay, then goes up, then negative, then goes positive again, and then we have all these positive values, all right, located right there, and then a negative value there. It appears it probably looks like there's a pattern and it's not very sporadic. So because of that, we're going to say there appears to be a pattern in the residual plot of body weight or maybe I should say, I get it because this right here is actually our input of, yeah, body weight. All right, a body weight. And backpack weight. Backpack weight. Okay, so because this is all of our body weight x's. Okay, so I'm just going to label that on our plot right here. Body weight. Therefore, a linear model may not be appropriate. Appropriate. Okay, and there we have that right there. So because we see a pattern, if we see a pattern in a residual plot, therefore the linear model would not be appropriate. We probably would want to see if this were something, probably some more definite changes in the pattern, okay, something like that. Maybe a little bit more scattered throughout. Maybe this would want to go down here a little bit, and then maybe this one's up here a little bit, and we see a bunch of scatteredness, and so it doesn't appear to be any specific pattern in the residuals. All right, well, that is how we use a TI to find out what our least squares regression line is, how we can create a residual plot and find the residuals using our calculator, and also what we're looking for to determine if it is an appropriate model for a line or not. All right, well, good luck and God bless in the rest of your problems.